Welcome to a new teardown video. I am not going to call this a test video because I think I can't test this one because I miss an important part of this product. This is called a Sonifier and it's from Branson Instruments in USA and it's called LS75. So this is only the power supply as it says. So it's a supersonic machine where the other half is missing. So it's actually the thing that is vibrating that is missing. The most important thing as far as I know. So this is only the power supply. We got some levels and standby. We can power it on and off. I think this is maybe the tuning where you tune the frequency and then you check for the ampere or the current load, so you can see if you are in tuning. So there will be some sort of an oscillator, a power drive or something like that in this unit. This is not original. The two banana plugs here on the front, and it also looks like the top was taken off and is misplaced. See, this is of course the front and this is the back, so that is a little bit funny. It is very heavy, so I had to pause the video to pry off. Okay, so we can pull this off and then clean it, snap back in somehow. I don't understand exactly what that means. And it says something about high voltage cord. I guess it is this one. Ooh, 2.2 amps. That is a lot of. Okay, this is what it says. What it use, and they recommend a 4 amp fuse. And another thing, you saw this was made in the USA. Where did you see this fuse before? HP. Right, so this is exactly the same fuse socket as you see on HP gear. So that is pretty good. So that is definitely a spare part if we are going to scrap this unit. I don't know yet. This also don't look like original. Some bananas here, so this is maybe for an amp meter or external something. It is also loose. I am not going to power this up before I've seen what is inside. So I think it's teardown time already. Let's try and do this together. Oy, 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 oy. What have we got? Oy. Look at that. So the main transformator is completely gooped in some nice stuff. And that will be some super sexy diodes and a bulb. And what? There's another one here on the back. And what the heck? So that would be for ballasting or some. Wow. I am so sad that I don't have the transducer for this product, because it could have been a lot of fun to see what is going to happen. We got some big bad boys of transistors down here. Wait, look at that. So all those big fat wires, they go. So this is just a pot for the tuning. Why is this supposed to be this big? Okay, so this is remote tuning. That is all it does. This is not an external transducer. So this is just the tuning pot. I guess this will be the on-off switch, and then this will be the tuning pot, or maybe it's a voltmeter so we can see what it is or something. Yeah. What is this? We also got some. Okay, we got some more good old stuff up there. Some golden transistors. It looks a lot like they're in parallel or something like that. Resistor, and then don't know exactly what to make of this. Those are some really sexy bulbs. Ooh, oi, 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 oi. Here we got the nasty business end. Oi, 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 oi. This is a high frequency, high voltage bad boy. This is something you would find in a TV set or something like that. Whoa. So this thing can make high voltage like you are not going to believe it. Yeah, that is definitely, you need to have big respect for stuff with this type of transformators. So that means we rectify something, make a lower voltage, self-oscillating something that is working in this. But so the AC, high voltage AC goes out because this is ultrasonic driver. So it's probably going out in those bananas. They're probably, oh yeah. So this is, see, probably this output was supposed to be here, and then it went through this banana. So this is just for an external amp meter. Maybe this amp meter is blown up, or it's not accurate enough, or something like that. It looks a lot like it is connected, but it could have been shorted or something. Yeah, definitely a very interesting unit. I think we're gonna open it a little bit more, see what else is in here. This is absolutely interesting. But I think it is very deadly to power it up. Oh, look at that. I want to see what is written on the... Ooh, yeah, this is falling apart. That is just how it is. This thing could have been from the 60s or the 70s. So it says... why can't we see that? Here we go. I removed the fan so we can easier see what is going on. I'm not really surprised. The fan is a 105 to 125 volts. So that means we can't use it exactly as it is. It depends on if it's if we're using it together with a transformator with a center point. Then we can of course use it. Let's try and give it 120. Ooh. It is 16 watts. And it's really powerful. But I can hear can you hear this? Bearings are completely dead. So that we can't use. What else did I find? The bulb. It's not really a bulb, but it's like one of those classic neon bulbs, neon indicators. And let's try and see if it works with my neon tube tester. Ooh, yes, it works. I love this neon glow. So that one is working. It was supposed to be completely transparent, so it would have been a lot more bright when it was new. But the amp meter is really nice. I've seen this design before. I think it was HeatKit. They're also using this kind of design, and I connected my power supply directly to the amp meter and actually the circuit that is there. So let's see how it reads. And this is 3 amps. Okay, that was good. And then 2, 1, 2, 3, and off. All right. Oi, that was fast. Ooh, so it's stage extends. Yeah. This is a very classical thing. Some of those plastic types, they are very, very static sensitive. Yeah, I found the tuning. Can you hear this? This is a wire wound power pod, and it is 30 ohms to 0 ohms. So this has something to do with the tuning frequency. We're gonna go and try and pull the whole thing a lot more out so we can see what it consists of. What I do see here is, look at those nice gold plated transistors. Those are really, really powerful. And they're all PNP, so this is very classical for the beginning of transistors. Everybody used PNP transistors. So that is of course what it is here. And the two halves, they're isolated from each other, so there's definitely a half wave push-pull, and those two, that will be the drivers. So this is a power drive oscillator. I was actually thinking about trying to power this up. It shouldn't be that dangerous. I think it could be a few thousand volts or even more. It depends a lot on how this transformator is configured. We also got an inductor. One of them is actually an inductor. So this is the transformator with all the different windings, and all the windings, they go to this. So it's sort of a pre-selector. So how many volts do you want, or something like that. And then we got the inductor here in series with the output, I assume. I haven't figured out about the lamps yet, but they are 12 volt lamps, or at least this one is a 12 volt lamp, and that one works. But I'm a little bit worried about the other one, because it says here, this capacitor, it says it's a dry. So it says, but dry means it's not containing any liquids, right? But so how is this possible? This bulb is completely full of some sort of a liquid, and it is kind of glued or melted itself in the socket. So there's no way I can get the bulb out of the socket. So I need to cut the wires and get all this out, and just try and see if I can get this out. But I want to keep everything in contact, because I think I'm going to try and power this up and see how much it's going to explode, or what kind of voltages it can, or damage it can create. It's the temptation is just too big. I was getting ready to power this up, but then I realized that it may not be such a good idea after all. I've been looking a little bit of the connections and what is doing what here. So this is the inductor. See, the black wire is the center of the switch, and this is used to select the different outputs of the high voltage windings. See this kind of orange, it comes up over here, and this is the external fuse or the connections they have, and this is one of the outputs, and then this is the power return, and this one goes down here to some other stuff. I haven't really figured that out yet. But then there's another one, and that is the black wire. This goes to the bulb, and the other end of the bulb goes to the potmeter and stuff. So that is of course for the drive to the oscillator. So that will be like a pick-up part of the transducer. So we've got a power part and a pickup part. And they're not, electrically connected together. So the pickup part is connected to the chassis, and the power part, that will be the other two pins. So that means there's no way I can power this up and get it to generate dangerous high voltage without the correct transducer. So that is just really, really a shame, because I kind of love high voltages and sparks and stuff, and it could have been fun to make some nasty sparks. So no, it's not gonna work like that. So I took out the main power drive circuit, and it consists of two halves of doubled PNP transistors, and they are connected exactly the same way, the two halves. So I think this is the two emitters, so they share the current. That will be the collectors, and that will be the base. So, and the base goes down to one of the transformators here that is driving, and the other base signal here that was connected to that one, right? So this is a push-pull kind of system that triggers the two halves. So the two collectors, see that it will be a thick orange one and a thick blue one. That goes to the thick blue one, and the thick orange one, that will be the two halves of the high voltage step up. And there's a center point here that is green. That one goes to the DC amp meter, and this goes to the transformator. So what, it's running off AC, and every time the AC is positive, this one can do some stuff. So there isn't any rectifiers or anything here. It's just doing its thing on the two halves. So when one half is positive, one of the PNPs here is doing its oscillations at high frequencies, and then the other half of the mains wave is positive, then it's the other halves doing its oscillations and stuff. And this way you don't have any rectifiers or any DC rails or anything like that. That is really a funny way to do it. And what we got here, the two small ones here, that is of course the pre-driving. And look at that, it's also coupled in a push-pull way, but that is involving this transformator. So I guess this is the oscillator or the pre-drive. And remember what I said about the input connector with the 4 pins, and one of them went to the bulb and it went back to some of this pre-drive stuff. It's also connected with some of this stuff to the first section of this power drive, or different voltages and stuff like that. Remember, the first setting is standby mode, and that first setting actually disconnect the feedback exactly as I thought. I don't know if we can see this, but down here it is disconnected. That is the standby mode, and that proves my point. It's not going to oscillate when the input drive or the input sense from the solenoid or the transducer. I would probably call it a transducer. So when the transducer is disconnected, there is no oscillation, there is no feedback, and nothing is going to happen. So that means we cannot power this up. So yeah, I might as well pull it all the way apart. But it was fun to see the different routings and the wires and stuff. Oh yeah, about this capacitor, I still haven't figured that out yet. Because look at that, it is also just connected to the mains. What? That is funny. And we also got two 24 volt windings. It says here 24, and there's another one on the other side. It's the same white, and they, both of them, go to those two. Bada bing, bada boom. So that is rectified, and then we got some DC here, and this is the decoupling capacitor, yada yada. So that is some low voltage DC just for this oscillator that is running all the time, I guess. Yeah, maybe I should try and boot it up and see if this oscillator is actually running. Yeah, there's no need to cut anything to pieces before I tried all the fun thing. As much fun as possible without getting killed. let's have a look at those transistors. They're really, really nice with this golden look. 2N350A. So that is definitely PNP germanium. That is a 2N2070. What does it say? Yeah, it's 77 or 76, yeah. It's a little bit difficult to see because of the... Yes, 76. They are really big and beautiful. I wonder why did they number them? So those are 31, 32, 28, 29. So what is the idea? Well, I think I'm not going to do any more with this now. I think we're gonna call it a day with this thingy. But it was fun. Those are really some beautiful PNP transistors. They're very, very heavy. Remember, they're rated 170 watts. And we got 4 of them. So this unit could really deliver some power. And of course those are germanium PNP transistors. So that means the crystal is mounted on the top of this pointy thing here. I'm not going to open these because they can really be of great help when I'm restoring some equipment. So it's really, really good to save stuff like this, especially germanium PNP transistors in TO3. Let's look at something else that was quite funny from this. This is very, very lightweight. Oops, let's do it this way. What does it say here? 85 Celsius. So this is a mini-mite dry electrolytic capacitor. So I think this means 2000 microfarads, 25 withstand working voltage DC or something like that. And this is the voltage peak, short pulse 40 volts, made in USA. All right. So let's try something really, really funny to try and measure it using a few different devices. So this is a fluke that can also do capacity measurement. So let's just try and measure it. I did short circuit it and I didn't power up the unit. And here we go. 5 point something microfarads. It's changing a little bit. So that is this type of method. Of course, it doesn't say anything about what frequencies or currents or whatever it's doing, but this is the kind of measurement you get using this instrument. All right, let's try another instrument. So I'm gonna... Oh, come on, man. It's going to be real difficult to get a good connection here. Okay, so it's good connected. And this cable goes to this England thingy. See, I'm in auto range or a manual range, a maximum of 20 microfarads, and it's overloading. What? Range, other. What else can I do? What kind of range can I do? The maximum range is 10,000, and it's, I can of course say all range not working. Really? Let's try something else. Oh, we got something. Or was it because I removed? is going to take a 10-minute measurement. So you just go to auto 10,000 and then, oh, hell yeah, we got a value again. 5,700. What? This is exactly the same value as the fluke, right? So it actually worked. Oh, it was just my patience that was the problem. Okay, let's try another instrument because this one didn't work before. And I am again in. Let's try again. Let's do the same auto range and see if there's any magic. Are you going to work or are you not going to work? I can see it's doing some blinky blinky manual thingy not working. Or at least, I don't know, half an hour to think about it. I gave up on this before. Maybe we should try and disconnect and then connect it again and see if... No, I just get this overload. Hello, hello. At least it goes to auto 100, but it's... So this meter is absolutely useless when it comes to this, and it all comes down to the frequencies. Let me show you why this is such a problem. Yeah. So, let's connect the last instrument of today. This stuff. This one got the ability to change frequencies that it's measuring. So this is more likely the right frequency between 4 and 5. But let's try and increase the frequency a little bit. See what happens? It's more or less the same, right? Oh, I'm stupid. I'm sorry. What I wanted to do is I wanted to do it slowly. See? Let's go down again. So I'm slowly increasing the frequency, and of course you can use some software to make a nice curve, and then you will see exactly what is happening. So when the frequency gets up to a certain point, then something special happens, and it's of course called self-resonance, and I think it's going to happen quite soon. 1 kilohertz. Ooh, now something is happening. Look what happens now. Oi, oi, oi. And then 2. See, here it goes absolutely bonkers. So that was 2.5, and then it goes the other way around. See, now it's inductive, because that is why you get negative capacity. So now we are on the inductive side on 2.5 kilohertz, and of course if I go further up, it just wraps around, because time is now negative, right? Or yeah, I don't know how to explain you guys this if you don't know what I mean, but it's, of course, this is gonna go crazy negative. So that means we had a self-resonance capacitor at 2.5 kilohertz, and that is of course why it is tricky to measure with different kind of equipment, because they're using 1 or 2 or 3 or 5 kilohertz or something like that. Then they just go absolutely crazy. But it's funny, it's nearly double the value. Maybe we should try and open this thing and see what is inside. So let's see if this is easy to open or not, but it looks a little bit like there's a metal can. Okay, so this is just... That's too easy. But there's a little bubble here. Ooh, psst. But you said dry, so why are you full of all sorts of puke? Ooh, so this is indeed... It is indeed the puke that is inside this one. Oy, oy, oy. This one looks like the same kind of dried puke. And now I screwed up my cutter. Damn it, damn it. Oh, look at that. That is the goopity goop. But how can it be so? They say dry. What kind of dry stuff is that, huh? my god, this is open. This is going to be real fast. The smell is... Yeah, open the door. More. Open. Oh. Are you kidding me? There's a very, very special stinker to this one. It's definitely not anything. It is not dry in any aspects of anything. Fuck me, this is gonna go outside again fast.